Internet Protocol version 6. The good reason why I should move to IPv6 is not only the address space. The best reason, the good reason is the header is a simplified header. That's what always I say first point. Simplified. Simplified header. Meaning what? If you'll see the size, amount of byte the header uses. IPv6 header is very less compared to IPv4. You may think like, how is that possible? IPv6 has got 128 bit of source and destination, whereas IPv4 is only 32-bit source and 32-bit destination. Now, how can IPv6 header be simplified? How can IPv6 header is smaller? Actually, the IP address only big, but all the rest of the field that you have in IPv6 are small, and also less number of fields. IPv6 have less number of fields in the header. Let me show you a picture. Now, the headers, you see, very less number of headers, the fields in the header. Version, even here you have version. Traffic class, type of service. And then flow length will be the total length. And then the payload. Here the payload will be there in the option field. Next header. Next header is here the protocol. And then hop list, hop limit is the TTL here. And then the source and destination address. All other fields in IPv4 is not seen in IPv6. Not only that, this IPv4 header is fixed. It's fixed. Even if there is nothing to carry in option field, that field will be there with some junk values. In padding field, there will be something junk, even though there is nothing to add. Likewise in checksum and flag, whether you use flag or not. When do we use flag? Whenever we want to have a special service like TCP sync, TCP ACK, reset, retransmit, then you need flag. But what if I don't send sync packet now or anything, any special, but still that flag values will be there. That means the bits will be there, at least 0000. But when this packet is received by any device, it'll just look into what is inside. Even though there is nothing, it needs to open it, it needs to read and find if there is anything interesting, which is a time consuming one, which is a process consuming one. So in short, what I want to say is IPv4 header is fixed header, IPv6 is simplified header, meaning whatever the fields that are necessary, only those fields will be seen in IPv6. And if only flags needed, that will get attached. If not, if there is no flags needed, then that field will never be seen. As a result, there is no need for uh, additional process. Whereas here, every time, all these fields, even if there is nothing to carry, will be there with some junk values. And every device will process this wasted time and processor. Process utilization is going to be higher and more time taken for IPv4 to get processed. IPv6, whenever you need some field to carry some information, it gets added. For example, IPsec. In IPv4, you don't have IPsec in the header. Then if you want to do IPsec VPN, then it will be an additional layer. Additional layer, ESP. Whereas in IPv6, you can have one small field, no header. In IPv6 header itself, you can have an IPsec header. Extendable, that's what I want to say. IPv6 is extendable. Whenever you want some special service, you can extend the IPv6 header to support that special service. You no need to have additional layer of encapsulation, which is going to be overloaded. In IPv4, always overloading. Sorry, yeah, correct. In IPv4, if you do GRE tunnel, then there will be GRE header. If you use MPLS, there will be a separate MPLS header. If you are doing IPsec, there will be ESP header. Not header, yeah, correct, header. A separate header is getting added, not the field. In IPv4, an additional header, which is going to be over process utilization. For all millions of packet, you are going to have additional header in IPv4 for additional services. Whereas in IPv6, because it's an extendable header, you're just adding a field for new services that you want to have. Now, this space may look big because this is only 32-bit. IPv4 is only 32-bit size. Here it is 128-bit size. But even though this is 128-bit, the time taken to process is less. IPv6 time taken is less than IPv4 because the other fields, the option fields, will have thousands of bytes. Thousands. Even though there is nothing to carry in the option field, those thousands of bytes will be always there to be get processed by every device in the path. So it is simple, extendable. We should never forget this point again. The IPv6 is the fastest uh, packet because the IPv6 header is simplified and extendable. Whenever you need new service, you extend by adding a field. That's it. Very compact. Now let's go back to our. So we are trying to understand why IPv6. IPv6 is simplified and extendable. Now we saw the size as 32-bit and 128 binary bit size is IPv6, whereas IPv4 is 32 bit size, binary bits. This is very big compared to this. That's why you see how big the size they have put. See the picture here, the comparison they are doing. It is not just 4 times bigger. 32 multiplied by 4, 8, 12. No, not this big. Not just 4 times like this. It is in binary. It is very big. To prove that, I would like to take an example. I got 3 bits here and 4 bits and 5 bits. Now, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Yeah. So the value 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, and here 2 to the power of 3 is 8, 2 to the power of 4 is 16. Now, let's see. The face value of this, the total value of this is 7. 7. The total value of this one is 7 plus 8, which is 15. The total value of this one is 15 plus 16, which is 31. Please see here, only one extra bit I added here. I got double, and again I added another one extra bit. This one, the 5th bit. The early one was 4 bit. The previous one was 3 bits. It's 5 bit. Just 1 bit I added. And you see it has doubled. If 3 bit can give 7 address, 4 bit can give 15 address. Just 1 bit when you add, the number of IP address that you currently have will double. Right now, the entire world was managing for many years with 32-bit. If it would have been made as 33, we would have got double the amount of IP address. Let's say for 32-bit, you got 1 million, for example. It's more than that. I'm just telling you. For 32-bit, if you have 1 million IP address, 33 is going to be 2 million IP address for you. And when you make it as 34-bit, it is going to double and it becomes 4 million. Just doubles. And if you'd have made 35, it would have doubled and become 8 million. Actually, more than 8. You see, 7 doubling is 14, but it is 15 here. 15 doubling is 30, but it is 31 here. 16 plus 8 plus 4 plus 2 plus 1, 31. I'm just giving you a rough picture here. See, maybe if they make IP address as 35-bit, today our entire world will have sufficient address. The reason why we migrate to IPv6 is what they say is they say, hey, we are running short of IP address. The 32-bit address is not sufficient for the entire world. But I tell you, if you had made it as 35-bit from 32, we would have got sufficient enough amount of IP address. But instead of making it as 35, imagine they have made it as 128. Very, very big, very, very big. See here, 32, for example, I took 1 million. If that can become 8 million just by adding 3-bit. See how big it is, IPv6, 128-bit. Not just 3-bit added. It is 96-bit added. 96 bits added. Fine, so IPv6 is very, very big, more than what we imagine. This IPv6 is going to rule the entire world. Yes. With this IPv6, every creature on earth will be monitored. That big is IPv6. Not only human being. Human being will be monitored first from one place. Every creature on earth also can be monitored from this, with the help of this. It may be a flying creature like small mosquito helicopters. We don't know, but the inventions are there. Every day, new inventions. Today we say drone, but drone is nothing. There is something big coming, like what you have in Dubai, a small mosquito helicopter. That may become a major, big transport in future. Everyone will be flying, not on the road. Road is too traffic. Everyone will be flying, and every flying objects need to be monitored so that they won't dash. For which you need an address. This IPv6 address is well planned. It is like someone who has gone like 100, 200 years ahead, seen what is needed, and come back and like time traveler. It's well planned. The one who has given 128 has got a very big vision. Every single square feet of this earth, including oceans, mountains, can be given an IPv6 address. Desert. every square feet can be given an IPv6 address. That big is IPv6. So once for all, the addressing problem gets solved. It is said somewhere today's IT growth can only consume 5% of IPv6 address. So today we can only use 5% of the IPv6 address. All the rest we don't have a reason to use. So we have really a big ocean of address left. IPv6 is really big. Okay, if IPv6 128-bit is big, then how we are going to write it? 32-bit IPv4 address, many are struggling to write. If you ask me what is your IP address of your laptop, I say 192.168.1.64. I know this is my IP address because I teach with Wireshark and I can see my Wireshark shooting packet from this source address. I see this very often. My DHCP giving me the same address, so I know it. But now, if I don't do such delivery, if I don't use Wireshark, it will be hard for me to remember this number 1.64. Not everyone knows their IP address, but they use their computers for many years. Even if you show them their IP address, ask them tomorrow, they forget. Just 32-bit address cannot be remembered. Then how can 128-bit address can be remembered? Truth is, even though it is 128-bit, we can easily remember because it is well structured. I'll give you an example. Telephone number plus 91 080 73421 11 0. When you see this, what do you understand? It's India. In India, this is Bangalore, and this is one of the device in Bangalore, one of the telephone in Bangalore, India. Structured, well structured. When you see a phone number, you can say from which country, from which state in that country the call is coming. 080 is for Bangalore. Likewise, this 128-bit will have continent, country, state or provinces or whatever the location, with the organization and subnet. All this will be the network portion. And the rest will be the device identification. So you're going to have some fields, some bits which will point towards a country. some field which will point towards, sorry, the continent, the country, and then the region means like state, and then the organization, and then in that organization which subnet, well structured. So, like when you see a telephone from where this call is coming, as you know from where the call is coming, you will also know from where this packet is coming when you see the IP address. Even in IPv4, we have this, but not uh, that easy. In IPv4, for example, when you sniff the packet, I can see from where the packet is coming, where the packet is going, but that is with the help of an additional database. You see, this packet is sourced to US. Google, we are using Google uh, chat, Google call. We are using this Google call to attend the class. I can see the packets are delivered to Google and the packets are coming from Google. You see, source is 142, which is Google's address. But when I see 142, 250, 8220, I don't see Google there. But my computer says it's Google. How it knows? Because my computer has got a database and it compares this IP address with the database. And database says it's US, Glencoe, Google, AS number 15, 16, 9, coming from United States. And when I try to access some local website, www.yahoo.com, and now let me TLS. If you see my TLS, it will say it's coming from Bharti Airtel, Bangalore. Because I was trying Yahoo. They have a server here in Mumbai. Let me stop. And this is US. 3.6 is US. It's US Amazon. Amazon. Maybe in web pages, there's some advertisements. So that's from Amazon. 18. This is also from Amazon. US. And this is from Bharti Airtel, Bangalore City. You see, 104 public address is given to Bangalore. But it is not well organized, you see. 104 is Bangalore, again 18 is US. We don't have a clear picture of these things. IPv4 is not well structured. You need to use a database to find from where the packet is originally coming from. Without database, you cannot see these things. But to tell that this telephone number belonged to to tell you that this telephone number belonged to India, Bangalore, I did not use any directory. When I see 91, I'm very sure it is India. I did not use any directory for that because I live in India. I know the country code. Because I live in Bangalore, I know the Bangalore location code. Likewise, everyone knows their country code, their location code. Likewise, everyone will know the first half of their address will be same for the entire person, entire people in that office. Half of the size of the address, like out of 128 bit, The 64-bit, the first 64 bits is, is to identify the network to which the packet belonged to. In that 64 bit, the continent, the country, the organization, all will be included. So it is always going to be same for that region people. And when you go out of, say, for example, this is Asia, India, and Bangalore, Karnataka organization is Cisco. So everyone who works in Cisco, they will have these fields, at least 48 bit out of 64. 48 bit out of 64, same. Only the subnet bit 16 bit may vary from one department to another. This first 48 will be same. The last 16 bit may vary from one department to another, but for the same department people, even that 64 bit will be same. And when you come out of Cisco, then this portion will be same for entire Bangalore. And this portion will be same for everyone in India, whether he's in Delhi or in Kashmir or in Telangana or in Kanyakumari. This portion is going to be same. And when you go out of India, every country in Asia is going to go have this thing same. So subnetting is summarization is very easy now. When I see this portion, I understand from which continent it is coming from. And when I see this portion, I see it is coming from India. So summarizing, when any packet goes out, when you advertise the networks of the India region, you advertise it up to this bit for all those regions in India. But when you send out of India, you advertise only this much. You no need to say in India this is Kerala. You no need to say in India this is Ahmedabad. You no need to do anything like that. You just say summarize to India and send the packet out. And the receiver knows that it's coming from India. And he shoots the packet to the gateway, and from there it gets in detail. So summarization is very simple. Easy summarization is another reason why we need to go with IPv6. Easy summarization. So far, what I have said is easy summarization, well structured, and simplified header, extendable header, more than sufficient. IPv6 is more than sufficient. Too much. You will never run out of IPv6 address. We'll always have for many generations. This is going to remain same if God's coming get delayed. So here we see a lot of advantages. I'll take it to more advantage now. In IPv4, we have DHCP, which uses UDP 67, 68 port numbers. This is a service which always does broadcast, a layer 2 broadcast. Because of this, lot of attacks are possible. Because we send broadcasting our MAC address. Hey, this is my MAC address. Can you please offer me a IP address? We are sending this as a layer 2 broadcast because we don't have IP address. We are sending as a layer 2 broadcast, asking everyone, is anyone there who can offer me an address? Now, that anyone among them, there is one good guy, one bad guy also. The good guy wants to give you IP address, the bad guy wants to give you illegitimate IP address, maybe. For you, wow, someone is giving me IP address, but he is an intruder. He gives you an IP address and the gateway so that whatever you send out from your PC will go through his network. See how dangerous it is. An intruder providing IP address, which is called as DHCP snooping attack. Or when I send a layer 2 broadcast asking for IP address, I may get an IP address from a legitimate server, but when I send that broadcast, I reveal my unique identity to everyone. My MAC address is what I'm talking about. I reveal my MAC address to everyone, but what if in that everyone there is some bad guys? He knows your identity now. He knows your original address, MAC address, your unique address. IP address keeps changing. That's okay if someone knows my IP address. It's okay. But when someone knows my MAC address, which is always going to be same, never changes. And if they use it in a wrong mode too. Hmm. So how do we prevent these things? In IPv4, no option. Layer 2 broadcast is always there in DHCP. But in IPv4 you cannot escape from without DHCP. If you want to provide IP address to thousands of computers, it's not that easy. So you have to depend on you have to depend on DHCP, and you have to compromise with all this thing. You open gates for attacks when you do DHCP, layer 2 broadcast. But in IPv6 there is a solution. In IPv6 we don't have any services in IPv4 that does broadcast. There is no service that uses broadcast is seen in IPv6. Only multicast. IPv6 replaces multicast instead of broadcast. That solves the problem. So we learned that IPv6 is the best solution because there is no broadcast. What about ARP? In IPv4, we have ARP, Address Resolution Protocol, which is also doing layer 2 broadcast. What about this ARP? We don't have ARP. In IPv6, there is no ARP. Yes, there is no ARP. We don't use DHCP like what you have in IPv4. We have DHCP, but not like what you have in IPv4. That's what I said. We still need IP addresses dynamically assigned. to our devices. We still need the DNS address, the gateway given to us dynamically through a DHCP server. But we don't have DHCP like we have in IPv4. We don't have that DHCP which sends broadcast. The DHCP in IPv6 is going to use multicast. To get an IP address, you really no need any DHCP. But to get gateway address and to get DNS address, you need multicast based ICMP version 6 DHCP. So we need to now have different perspective now. It's not same like before. Before we use DHCP to get IP address, to get mask, to get a gateway address, to get DNS address. Sometimes we also use Win server address. To get all this, we were depending on DHCP. But today, in IPv6 world, you can get IP address without any DHCP support. All that this is needed only for gateway, DNS, if there is wins. Then who gives IP address in IPv6? Auto configured. Even without this DHCP, we can dynamically get IP address configured in all the device. See how nice it is, IPv6. No DHCP needed for an IP address to receive an IP address dynamically. We use something called auto address configuration. When we go there, I'll explain you. But as of now, one thing I want to very clearly say is all those things which was dangerous for us to use, which we were tolerating, even though it is dangerous, we were still using it. We still use ARP, we still use DHCP in IPv4 world, even though we know very well that they are dangerous. All those things are removed in IPv6. So IPv6 is truly secured way of communication. IPv6 way of communication is a true secure way of communication. All those things that is threatening us is not there. No ARP, then how do you learn MAC address? If there is no ARP in IPv6, we use ARP to learn the neighbor's MAC address using IP address. That is what ARP. In another word, we can say using ARP we do neighbor discovery. Learning neighbor's MAC address is what called as neighbor discovery. In IPv4, we send a layer 2 broadcast asking who is 10002. And our reply comes saying, it's me, this is my MAC address for 10002. That is how the neighbor discovery happens. It's layer 2 broadcast. In IPv6, if there is no ARP, then how neighbor discovery happens? How MAC address gets learned? For that, we use ICMP version 6. Even this DHCP in IPv6 uses same ICMP version 6. This is going to use a multicast again. IPv6 multicast to learn the neighbor's MAC address. So there is also a special address type involved in learning neighbor. We call it as link local address. Link local address. Yeah. So IPv6 don't use ARP. It uses ICMP version 6 multicast, and with the help of a special address type called link local, the neighbor's MAC address is learned. This is a kind of layer 3 address, but it starts working from layer 2 itself. So in order to learn the MAC address, you use this layer 3 address called link local address. Because for multicasting, to do multicasting, you need this link local address. More detail is coming later. I'll debug and show you. One thing very clearly want to say here is there is no ARP. There is something called ICMP version 6. And there is a special address type called link local address. And this address will be always starting with this number FE80. The remaining part can be anything, but the first 4 digit is going to be always FE80. If you see an address FE80, then you should know that this is a link local address. Let us see whether I have a link local address in my laptop. ipconfig/all. If you'll see anywhere, look at this link local IPv6 address. It will always start with FE80. The remaining part is made out of MAC address. I'll explain you as we go deeper later. This is what I want to say. FE80 should not forget. This is going to help us to discover neighbor. This one is an old story. FEC0 and FEC and D0 is no more. It is removed from the industry standard. But still, I can see some operating system using them. They are called a site local address. They were called a site local address. It's no more. FEC0 and FED0. It's gone. It's no more used. Site local address. Right. Now, FE80 is the link local address, which is used for neighbor discovery, so no need of ARP. And there is no need of DHCP to get an IP address because we have stateless auto address configuration. Stateless. Stateless auto address configuration. Because of stateless auto address configuration, we no need DHCP to provide an address. But we do use the DHCP to learn only the address of the gateway, DNS, and again not broadcast, it is going to use multicast. So the advantage of using multicast is the packet will not be delivered to all. It will be delivered only to those devices that are really relevant to receive it. So our packets are not going to be visible for attackers because multicast traffics can only be processed by the legitimate receiver. Others cannot process it. So if you have not learned multicasting, don't worry, we are going to learn multicasting. Then you will understand how multicasting can achieve this. Talking to the correct person, not to everyone. Talking to the group of people who are supposed to receive it, not to everyone in this network. Broadcast is talking to everyone without knowing to whom I'm sending. I send. That is broadcast. Anyone can receive it. Okay. Now, when I say about DHCP, I was using a word stateless. IPv4 DHCP is stateful. Why? If you see in IPv6 DHCP, the second packet, the first packet is discovered going from client to the server. The second packet is from the server to the client, and we call it as offer. Offer. Now, this offer, if you see, the server will offer an IP address after learning the MAC address of the client. That is why we call it stateful. It learns the MAC address of the client and say, okay, for this MAC address, I make a note. For this MAC address, I give this IP address from the pool. I propose this IP address. I propose, I offer. I'm willing to give this IP address. So after learning the MAC address of the client, server can do this. Without learning MAC address, not possible. That's why I say stateful. But in IPv6, it is stateless. Uh, there is no actual client-server relationship in IPv6 to receive an IP address. You're not having any server or client relationship, but you still have an IP address dynamically configured through auto address configuration. So it's a stateless auto address configuration. No one knows my MAC address. But in DHCP, IPv4 DHCP, the server knows all the MAC address of the client. Then, if attacker becomes a server, DHCP server, he knows all MAC address in your office. If someone brings one small access point, a small domestic router, connects the router to your network, what will happen? When there is a DHCP discover packet comes, that attacker's router will respond. It will capture all the MAC address and it will start giving IP address, gateway address, which is an attack. DHCP spoofing attack. That's called DHCP spoofing attack. Yep. So it's very dangerous, learning our MAC address, someone without knowing who the someone is, whether he's a legitimate DHCP or a rogue DHCP. That's very dangerous. But we were managing these things. We were having these things for this many years. It's no more. Stateless auto address configuration. IPv6 address, I said it is 128-bit, in which the first 64-bit is called as global prefix. Global prefix. We used to call network ID, host ID in IPv4. Here, there is no network ID. Terminology is changed. Term network ID is changed with this word global prefix. Prefix is nothing but length of the bits that are given for something. Here, 64-bit is given for identifying a device globally. See, in IPv4, we have private IP address, public IP address. There you cannot call an address as global prefix. You can say only network ID. So it may be a private network or public network. But in IPv6, you can very well call global prefix because no private IP address in IPv6. No privacy. No privacy in the sense, I'm not saying no security. I say you cannot hide behind natting. No natting in IPv6 needed. There is no need of there is no need of natting in IPv6 because you don't have private address, public address concept. Everyone is public. That's why I say no in the beginning. Small mosquito helicopters. All will be flying on the sky, not on the road. All these flyovers, metro trains, all this will go one day to the shed. And there's a big space where you can drive freely, for which all device needs to be under monitoring. IPv6 is a good option to achieve that. All will be visible. There is nothing on earth can hide behind a mountain. Every square feet of earth can be given an IPv6 address, I told you. And it will happen. So no one can hide, no one can uh, send a threat mail. Everything is going to be open, public. See how they have named the word global prefix. Globally, how you are going to be identified is being given there. That ID is given there. In this 64 only, I was telling you, it will have a portion which explains from which continent you are sending this packet, from which country in that continent, from which state in that country, from which vendor you purchase the internet, and in that vendor, who are you? Everything will be seen in that address. Globally, you are going to be identified. This Aadhaar card, social security number, all this will vanish. You will have a global prefix for you to identify yourself when you go through immigration. No more carrying visa and passports. You are already identified. System knows who you are. Yeah, as you simply walk in the system, beep, beep, oh, green, go. So globally going to be uh, identified. That's why they have named it as global prefix. And this remaining 64 bit is interface prefix. Means in that network, what is your IP? What is that unique ID given to you? Your device. When I say device, today I can say device, but in future we will not be able to say this as a device because it can be a human being identified with this address. Now, as of now, we can use the term device is getting identified. But sooner, people and animals will be identified. So you can very well say by seeing this full 128, this animal is from this continent, this country, this state, this region, and this is the animal's name. When an animal is imported from a country, you don't need to ask someone from which country it is. Not only for animal, even for human being, that is how it is going to be. You cannot deny these things. This will be forcefully given. And you will not say no to it because you need next meal to eat. This is the plan behind IPv6. But if I say this, it's too early and people will mock at me. But that is what the truth is. Truth will be bitter always. Now, there is no subnetting. There is no subnetting like what you have in IPv4. We do have subnetting, but it is not like as we have in IPv4. In IPv4, for subnetting, we used to borrow some bits from the host bits. But here you see, we don't touch this. We don't borrow any bits. As per the standard, there is 16-bit reservation only for subnetting. So you don't need to borrow, so there is no difficult subnetting here. Only when we borrowed, we need to know the increment value, we need to know the first address, broadcast address, all those calculations was a little bit difficult if you don't do with proper understanding. But in IPv6, you don't have that pain. For example, if I have a address like 2000 colon 9108 means India Bangalore colon and my company is identified with number 1, boom. This 48 bit is what the ISP is going to give me for my organization. Now in my organization I want 10 subnets. Very simple. I'll say 2000 colon 9108 colon, these leading zeros can be stringed 1 colon, and this is only 48 bit, but network is 64 bit, right? So here I'm going to say 0001. This is the first subnet. This can be written like removing the leading zero. 2000 colon 9108 colon 1 colon 1. This is the network for my company, and this is one of the subnet. I was given 48. Now I'm using a 64. How easy the subnetting is. You see, I got one network. And if I need another network, I simply increase the bit here. That's it too. And the 10th network will be A colon colon slash 64 because A is what we call 10 in hexa. IPv6 is hexadecimal, right? And you keep incrementing here up to what? 2 to the power of 16 because you got 16 bit. So in each 48 bit network, you can have 65535 subnets. These many subnetting you can do, these many subnets you can have. And in each subnet, you will have another 64 bit given for interface. So in each department, you can have millions of IPs in each department. That is why you are going with SD-WAN and automation. Imagine if in each department, why you need millions of IP? Something big is coming. And to have millions in one department, and where like that, if you want to have many departments, to manage that, to control that, you need to provide that fast service to those millions in each department. You need a very fast network, not only network, a very fast application, not only application, you need very fast application based policy driven uh, technology. That is where this software defined and all coming. Who knows? The entire world will be classified into different groups in networking, and each group will have millions of people. And to put them in one category, they need this. We don't know now, but these guys, who propose this, they are not human. Something else. Now, subnetting is easy. I showed you. There is 16-bit reservation. So when you try to buy an IPv6 for your organization, they'll ask you, like, how many IPRs do you think you will need for another 10 years? Then you will, based on what you say, they are going to give you /48 or /36. /48 means this many are already masked. They give you. You cannot change this value. Yep. 32 means this is masked. This you can do anything. These two excedates. So depending on how much IP address you need, how many IP address you need in next 10 years, they are going to decide the length and give you. Even in between 48 to 64 also they will have some length. Because recently to one of the country, not to company, to one country I purchased this IP address for for one African country. For the entire country, they give like 32/32. From that point only, the internet goes to the entire country. IPv6 address will always start with 2000, something like 2000 or 2001, 2002, something like 2000 only it will start. The reason is in the year of 2000 this became standard. That is why. So they could have started with 0001, but no, they're not starting with 001. Uh, Starting with 2000 always. Maybe 2000 or 2001, or it will always start with number 2 for sure. And here this will keep incrementing as many get inside IPv6. Region wise it will vary. But the number 2 will always be there in the first hexabit. Now 128 bit. First half is network, second half is the device. The first half is called as global prefix, the last half is called as, second half is called as interface prefix. But the whole address is 128. When you write it, you can shrink it and write it. If you don't shrink it, it will be too big. Say, for example, I have 2000 colon 0001 colon 0001 colon. This is 128-bit IPv6 address. How can this be 128-bit? Because it's not a binary, it is hexa. Because it is hexa, 128-bit will be only 32 bits, 32 hexa bits. You see, 4, likewise I have 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 multiplied by 4 is 32. So you will have only 32 hexa bits. 32 hexa bit is equal to 128 binary bit. How? How 32 hexa bit is 128 binary bit? One minute, it is noisy. How can a 32 hexa bit be equal to 128? Okay. If you take hexa, the number starts with 0 and ends at F. F is 15 in decimal. Decimal 0, decimal 9 is hexa 9, decimal 10 is A, 11, 12, 13, 14, 15, A, B, C, D, E, F. Okay? F is 15. So you need just only one bit to say 15. Just only one bit. In hexa, you need only one bit to say 0. It's the same one bit you need to say the biggest number 15, F. Whereas in binary, to write this 15, the biggest number of hexa, you need 4 bit. 2 to the power of 3, 2, 1, 0. This is 8 plus 4 plus 2 plus 1, 15. So in order to write this 15 in binary, you need 4 bits. In hexa, it is just only one bit. Which means this is in binary. If I need to write in hexa, I need to divide by 4. Because binary is more. When hexa is only 1, binary needs 4 bit. So this is more, 128. 4 times more the binary bits are. Then if I need to write in hexa, I need to divide this 128 by 4, which is 32. See, you have only 32 hexa bit in IPv6. 128 binary bit is equal to 32 bit hexa. Now coming back to our, if you have any question on this, you can ask me now. No questions? Okay. So you were all awake. I thought you all slept. Okay. Now this 32-bit this 32-bit, you don't need to write this big 32-bit hexa. If you'll see these leading zeros, you can avoid them. There is no weightage for that. But these 3 zeros behind this 2, they have weightage. If you remove that 3 zero, it becomes 2, not 2000. It becomes 2. But when I remove these zeros, there is no value change. There is no degradation. It is simply 1 always, even if you have 0 or not. This is 1 only. So I can write like this. Leading zeros I can omit. I can say 1. Again, leading 0 I can omit. I can say 1. And if you see consecutive zeros like this, you no need to repeat like this. You just put colon, colon. Enough. Nothing. Don't fill any 0 here. colon colon. Again leading 0 you can omit. Again leading 0 you can omit. That's it. If you type this, computers will understand this. Let us try giving this in my computer. Let's see what happens. We got IPv6. Now I'm going to say here 2000 colon, what did I write there? 1 colon 1 colon colon 25. 1 colon 1 colon colon 2 colon 5. And prefix length is 64. The mask. See, it has automatically given. Gateway I'm not willing to give now. Let me say okay. Done. Now let us see what it shows when I go to properties. Sorry, not properties, status. Okay, I don't see. Okay, because the link is not connected. We can see in command line. I give an address starting with 2000. What's the interface name? Give to Ethernet Broadcom. This is the one. Okay, until I connect the wire, I cannot see that. Let me try giving to the wireless interface which I'm talking now. I'm going to simply give one IPv6 address. Simply like this, DAD colon 1/64, which means a lot of zeros in the middle. Sorry, 64 you don't need to give, it will automatically give. Not giving, okay. Because this is not as per standard, it is not giving 64. 2000 is what as per the standard. Okay, now let's go and check. I'm looking for the wireless interface. Here it is. Look at this. But it is actually an IPv6 address of 128-bit size. In some operating system, you will see a lot of zeros automatically filled. That's what I was curious to show and see. But unfortunately, this is showing what exactly I typed. It is not expanding with zeros, but it automatically takes, it understands what you mean. Actually, when I say DAD colon 1/64, what does this mean? It means that DAD 0 here is four hexabits in a group colon. Likewise, last one is also 0001. all the remaining 6 hexadates. See, out of 8, 1 is here, 8 is here. All the remaining or 0, it understands. When you type like this, colon, colon, it understands this. That's it. So instead of writing this big address, you can shrink it like this and type. It is okay. It means that this 64-bit is network. That's the meaning of this. You can also say 128 if it is needed. If you want to fully mask, you can mask it. So there is a lot of connection between IPv4 and IPv6. In what way? In IPv6, how many bits you have in a group? We used to call this octet, no? How many bits? 8 bits. Here also you have that same number 8. 1, 2, 3, 4, 5, 6, 7, 8. So there is some sort of correlation. In IPv6, how many bits you have? 32 binary bits. How many bits you have here? 32 hexabit. Yeah, count and see. 32. In each hex date, you got 4 bits. So 4 multiplied by 8 is 32. Yeah. So there is some sort of similarity. As I was telling, there is a reservation FE80 for link local. For global, they are going to start with 2000. 2000, this can be 1, 2, 3, 4, any number. Link local is FE80. The multicast, the multicast will start with FF02. For example, what is the multicast address of OSPF in IPv4? 224.0.0.5. Now here in IPv6, it is FF02::5. You see, same 5 only, but this portion is equivalent to 224.00. In IPv4 EIGRP, it is 224.00.10. So what will be the multicast address in IPv6 for EIGRP? FF02::A, which is 10. So this is an example for multicast address. This is how the link local unicast address will start. This is a unicast address. Global address is also a unicast address. It will start with 2000. This last number can be anything. So IPv6, though it looks bigger, you no need to write that big address. You can shrink it by omitting the leading zeros. And you can put just colon instead of typing these many zeros. In that way, you can shrink it. Now, last thing for today, I want to explain is you can provide IP address to the interface with both global prefix and the interface prefix, or You can only provide the global prefix, and you can ask the interface to dynamically assign its MAC address as the interface prefix. But the MAC address is only 48-bit. You need a 64-bit interface prefix. How is that possible? It is possible because you're going to extend it. Extend that unique identifier. What is unique identifier in our computer MAC address? So when you extend the MAC address to 64-bit, you get a unique IP address. So you see, if you know the network portion, that is enough. You don't need to worry about the interface portion. You can also ask the router to dynamically assign. The other way is auto address configuration, which is only possible in IPv6. So these are all the different ways in which we are going to assign IP address in our first lab in next class. We will do a lab next class, and then we will go more into IPv6 learning. We need to do a lab now immediately after this. We'll meet again tomorrow.